There's a connection between the derivative formulas for sine and cosine that I'd like to point out to you. All right, and to do this, let's look at a couple of pieces of background information. Remember and I always call this the most famous of all trig identities, that the cosine squared of alpha plus the sine squared of alpha is equal to 1. Recall the product rule, that if I want to take the derivative of the product of two functions, I make two copies of the function. In the first copy, take the derivative of the first function. In the second copy, take the derivative of the second function. And let's assume that we know the derivative of sine is cosine, all right, but that we do not know the derivative of cosine. All right, I'm going to use these three things, the identity, the product rule, and the derivative of sine, to develop the derivative of cosine. And here's how we can do this. Let's take the derivative. We know that cosine squared plus sine squared is equal to 1. So let's take the derivative with respect to x, and let me rewrite this, I guess this identity as cosine squared of x plus sine squared of x is equal to 1. And let me take the derivative. These two things are equal, their derivatives are equal. If these two functions have the same graph, if they're equal, then the slopes should be equal. So I'll take the derivative with respect to x of the left side, cosine squared of x plus sine squared of x, and I'll take the derivative on the right side of 1. Well, of course, the derivative of 1 is 0. It's a constant. We could think of it as x to the 0. Then using the power rule, it would be 0 times x to the negative 1, but that would still be 0. All right, here on the left side, I can take the derivatives of these terms separately. So I'd have the derivative with respect to x of cosine squared of x plus the derivative with respect to x of sine squared of x. And notice, all right, that cosine squared is just cosine times cosine, sine squared is just sine times sine. So let me think about it this way. All right, I have the derivative of cosine squared of x, so that's just the derivative of cosine of x times cosine of x plus the derivative with respect to x of sine squared is just sine of x times sine of x. And this is equal to 0. Okay, now we could apply, to take the derivative, we have a product of two functions, so we could apply the product rule. All right, in this first example, I had to make two copies of cosine times cosine, take the derivative of the first cosine in the first copy times cosine, plus in the second copy leave the first cosine factor alone and take the derivative of the second cosine factor. We can do the same sort of thing for sine, because we also have a product. So take the derivative of the first factor of sine in the first copy and the derivative of the second factor of sine in the second copy. And all of that's equal to 0. Well, notice what I have here. Of course, multiplication is commutative, so I could multiply the derivative of cosine times cosine, or cosine times the derivative of cosine in either order, and I get the same thing. So what we have here in this first part is we have 2 times cosine of x times the derivative with respect to x of cosine of x. And we have the same sort of thing in the second part. We have 2 times the derivative with respect to x of sine of x times sine of x is equal to 0. I could multiply through by a 1/2, and that would get rid of those two factors of 2. And now what I'm going to do, I know the derivative of sine is cosine, so let's make that replacement. We have cosine of x times the derivative with respect to x of cosine of x, plus the derivative of sine is cosine of x times sine of x. And all that's equal to 0. Now let's solve this for the derivative of cosine of x. The derivative of cosine of x is equal to the opposite of cosine of x times sine of x, subtracting cosine of x times sine of x from both sides, and then dividing by cosine. We get the opposite of sine, which is what we had before. So really, once we had the derivative of sine, and we knew that that formula for the identities, cosine squared plus sine squared is equal to 1, the derivative of cosine was already cast in stone. These derivatives have to depend on one another. All right, there are other functions that have relationships similar to this cosine squared plus sine squared equals 1. Those are called Pythagorean relationships. There are two other Pythagorean relationships in trigonometry, and those will also lead to other derivative formulas too. But I'll leave you to derive those.